welcome back to Chicago Crossing Model Railroad. It's me, Eric, here with you for another session of Train Talk. And today I wanted to talk a little bit about wiring for small model railroads. In 1972, after years of flooding related to heavy rainstorms, the city of Chicago inaugurated a new project that was called the Deep Tunnel Project by everybody. It was actually called the TARP Project, or the Tunnel and Reservoir Project by the engineers. In any case, the goal of TARP, or the Deep Tunnel Project, was to use quarries and massive tunnels as rapid mechanisms for collecting rainwater that would fall during heavy springtime storms in the city of Chicago. It would all be funneled into decommissioned quarries, and there it could be dealt with in a way that didn't put it into people's basements or into viaducts or other places where the water shouldn't be. This was a major renovation among many of a sewer system that required constant repair and replenishment over time, particularly given the location and climate of the city of Chicago. I bring this up not necessarily because I want to give you a history lesson, but simply because in many ways the rewiring project of Chicago Crossing Model Railroad is not unlike the Deep Tunnel Project. It was a massive undertaking in order to correct deficiencies that were there really from the start. And so the key question for me and for you and anybody in model railroading is, well, how do we do things better so that we don't necessarily end up in a situation where we have to make a deep tunnel project underneath our own model railroads? And the situation is particularly challenging if you have a small model railroad. And that's because you don't really have a lot of geographic space to work with in order to contain all of the different elements that you might want for a fully accessoried model railroad. For a small layout with multiple electrical accessories, and that can range from signals to streetlights to illuminated buildings to railroad crossing signals, Arduinos, sensors, circuit breakers, you name it. Those elements all take up space. So does the wiring that's necessary in order to actually power them. And so if you're like me and you're working with a 7x3 or smaller layout, then how to fit all of that stuff into such a confined space and to do so in a way that is organized, functionally stable, and is easily serviceable can be a real issue. So with that in mind, I thought I'd use today to talk a little bit about my experience in reworking and doing the Deep Tunnel Project, so to speak, for Chicago Crossing Model Railroad. I'll share with you a little bit about what I learned and some of the insights that I gained that maybe will help you if you're thinking about planning a small model railroad and deciding that you would also like a lot of different electrical accessories or just want to make sure that from the start the thing is sound. In Chicago Crossing, if you look at it from underneath, it basically looks like 5 different little wooden boxes, and that's because the horizontal beams that form the support for the plywood base of the layout form these sort of individual sections. In its previous iterations, the wiring for Chicago Crossing was, well, I guess we could say informal. The DCC bus, as an example, was more or less a loop that ran from the DCC unit around the underside of the layout through those different support beams and over to all of the different feeders that required DCC power. In addition, the original power scheme for all of the streetlights, and granted there were many fewer early on, was all based on a couple of copper strips that the fine little wires from those streetlights were soldered to. That was in the center of the layout, and all of the wires from all over came down and collected into that one point, once again through holes that were drilled into the centers of the support beams that you see underneath. When I did the second iteration of lighting on Chicago Crossing during the CCMR at Night project, I replaced those copper strips with a motley assortment of terminal blocks for the streetlights, just plug light hubs for all of the different buildings and their lighting, and more or less just distributed everything almost in a haphazard or at least a random sort of way. Again, I didn't really sit down and think through exactly what I was going to do. I simply knew that I wanted lights on the upside of the layout and on the downstairs underground part of it. I wasn't really thinking too much about where everything went. Needless to say, if the underside of Chicago Crossing at that stage was anything akin to a sewer system, then man, I would not flush the toilets. So once I'd pulled all the wires away in order to reveal the bare plywood, that's really when the real work began. And so if you are starting a layout, if you know the size and shape and have even built some of the base of what your layout looks like, now is a really good time to sit down and be thoughtful and to try to plan out what it is that you actually want to put underneath there and how best to make it work. In my case, the loop of wires that created the DCC bus was replaced with a linear DCC bus that ran down the center of the layout. And this was done for two reasons. Number one is to make it easy to distribute that power to terminal blocks, and number two, to make sure that those terminal blocks could be located relatively in the center of the layout on each individual section. And what that allowed me to do is basically make sure that I could control the length overall of the feeder wires that were running from the track into the different terminal blocks. That bus in turn was fed over to the NCE power unit that I use for my DCC control, and I also incorporated a switch for that. Since the unit itself doesn't have its own power switch, that really saved me from having to turn on a power strip with my foot or to mount a power strip somewhere else. We'll talk a little bit more about power management later. Needless to say, I also decided to replace all of the solenoid pop switches that used to be on the layout with a different set of turnout motors that would be DCC controlled. This, of course, would let me clear the fascia of all of those Atlas power turnout switches that were mounted over there. And in addition, it also necessitated a second DCC bus that was protected by a circuit breaker. This was something that the manufacturer of the turnout motors that I used had suggested as a way to help protect them against power surges created by derailed trains or the like. You may actually think about that more along the lines of like a power district, since large layouts often have multiple power districts in order to ensure that certain parts of the layout can run if a train derails on another and shorts the circuit. And of course, the other challenge was, how do I deal with all of the different voltage standards that I have for all of the different accessories on my layout? I had Miller Engineering signs that run at 4.5 volts. I have a bunch of streetlights and other LEDs that run at 12 volts. And then I also have, on top of that, the Just Plug system, which I chose to retain simply because I already had it, and it would be much easier to just reuse it on the layout rather than try to sell it on eBay. So from that standpoint, I also had a 24-volt power system that I also had to run into the layout. So here, I examined a couple of different strategies that I could use. One strategy was to run basically just a single power bus into the layout, and then to convert the voltage down to some of the different standards that were necessary for some of the different items. And that's a totally serviceable way to do things. What I chose in terms of what I felt was most simple for my layout was to just run a voltage bus for each of the different voltages that I need, and then just drop lines down to the specific terminals that are necessary in order to distribute power from those individual drops. So in this case, the nice thing is, with limited space, those wires could be bundled together and really don't take up all that much more room than, say, a single couple of bus wires necessarily would. What I did is simply use a hole saw to drill a decent sized hole through the center line of the horizontal beams on the underside of Chicago Crossing, and use those as the pathway to run the buses into each of the different sections of Chicago Crossing. And then from there, each section can have its own drop wires. For me, that just seemed really simple. And it also matched well with both the power management and the power switch strategy that I wanted to use, which was to have each of those buses on an individual switch. The one final bus that I needed to run was basically a 12-volt unswitched bus. And this is for items that are on all of the time. Things like the dwarf signals at the front of the bridge, or for any number of different objects that might end up under the layout as I continue to work on it and expand it. And we'll talk a little bit more about that as well. So the bottom line is, even though that sounds like a whole bunch of different wires underneath the layout, the reality is that the geographic area that those wires occupy is actually quite small. Again, if one uses a power grid or a sewer system as an analog to this, basically these are just different size lines that happen to run for different purposes. And at that point, it's a one-to-one match between the purpose of that and the accessory type that it powers. For me, that was relatively simple. But again, it's one strategy and one right answer out of many different ones. The key element here is really habit of mind, is simply thinking beforehand about what you actually want for your layout and how best to achieve that aim. One of the biggest thieves of space on the underside of Chicago Crossing was a sort of wall switch mounted to a surge protector strip that was mounted to the underside of the layout over in what essentially is like the central section of the layout. You know, ostensibly, what this was supposed to do was to power everything on the layout. However, as I quickly began to realize during the CCMR at Night project, is that was absolutely insufficient. And at that point, I had wall warts in all sorts of different places, and this quickly, became untenable for being able to keep power management compact and to be able to keep all of the different wall warts and things like that into one place. It just created an additional mess of wires and stuff on the underside of the layout that was really not fit for purpose in my case. So this is where I came up with the idea of using a large bulkhead connector, a multi-conductor cable, and then a server rack to consolidate all of the different power sources for the layout. What this provided me was basically an easy and robust and durable quick release system to be able to apply power to the entire layout for everything using a single cable, to have all of that power run into another portable location, and to have all of that stuff be sufficiently robust and portable that if I ever wanted to show Chicago Crossing at a train show, it's easy enough to just cart all of that stuff around, and then in the case of the server rack, it's all on wheels anyway, so I can just wheel it over to wherever the train layout would actually be. To me, that just made sense in terms of ease of use. For you, if you don't envision taking your layout and moving it around a whole bunch, then those sort of things are not necessary. But again, we come back to two principles: offshoring the power off of the underside of the layout, consolidating it into one usable space. So what I elected to do is to use as the heart of the power supply system a computer power supply. Mine is rated at 480 watts max, and that supply has multiple voltage rails. In my case, 5 volts, which I can use for the Miller engineering signs by stepping it down just a little bit to 4.5 volts. As well as a 12-volt power supply that can be used for the vast majority of accessories on both the switched 12-volt bus and also the unswitched bus. And so basically what this means is I've got more power than I'm ever going to need for the layout, and that's really good when you think about expandability. However, given how much power that is, I also have inline fuses on a breakout board in order to protect some of the things downstream in case there was ever some kind of strange power surge coming from that device. So the supply for all of these items runs through a multi-conductor cable. I constructed it in front of you a while back, and then up to the layout. And from there, it runs in part to the power switches in the fascia. The 12-volt unswitched bus breaks off of that 12-volt set of cables just beforehand, and again, goes to the length of the layout so that it can power anything that needs to be there. And for a small layout, really having this type of centralization and keeping all the power supplies off of the underside opens up a lot of space that otherwise would be occupied by wall warts, power strips, and the like. Lastly, as a final measure of protecting all of the electronics on the layout, all of the power on the server rack runs into a power conditioner, and that power conditioner provides both surge protection and added stability for all of the different power needs for the layout. You know, an important lesson that I had learned from the previous iteration of Chicago Crossing's wiring scheme was that how power is actually distributed from a bus wire to the different components of a layout really does matter in terms of being able to keep things optimal, serviceable, and expandable. This was something I really hadn't thought about when it came to the previous iteration of Chicago Crossing Model Railroad. And the end result of that was, again, this sort of informal way that the wiring worked, which included, by the way, wires for certain things snaking into other sections of the layout with no clear origin or destination, wires that were not coded in any particular way that I could tell them apart. And it became really challenging from a serviceability standpoint. I remember this one point where a quarter of the streetlights on the layout went out, and I literally could not track down where the heck the fault might happen to be. As it turns out, that was one of the catalysts for actually deciding, okay, enough is enough, let's rip it all out and do it all over again. So once again, if I can save you that trip if you've already got a layout or if you're planning one, then let's try to do that here. So with this experience in mind, what I decided to do was to use the underside of the layout and its structural organization to my advantage, and to use the buses that run the length of the layout as a means to distribute power in ways that makes each section fundamentally identical in terms of what different powered nodes it actually has. So what this means is that for accessories like building wiring or streetlights or the like, each individual section has its own set of drop wires for that section, its own terminals for those different uses, and from there, only services feeder wires that emerge from the top within that same identical section. What this means is if an LED goes out somewhere over by the grain mill, I know exactly where to go in order to service or remove or replace that LED. It is within that section and only within that section. It takes out a ton of guesswork about where a wire might be going and what it might be doing. The one thing I learned, especially after lifting up the layout after a couple of years and looking at the rat's nest under there, is that the more accessories you have, the more boxes and terminals and things like that you're also going to have in order to be able to power them. And so for a small layout, that becomes another challenge because, of course, if you want all sorts of different things working on your layout, then you have to be able to make sure that you've got the geographic space to accommodate it all. So the big lesson learned between then and now was where to actually mount all of these different terminals. The temptation, and what I had done previously, is literally just to mount it all to the direct underside of the layout. And what you end up with as a result is actually a bit of a mess and a lot of stolen space. Instead, for the reiteration of Chicago Crossing's wiring, what I decided to do was to actually be really jealous about the underside space of the layout and to retain as much of that as possible for really necessary uses, such as fastening and dressing wires. Rather, the only terminal blocks that actually occupy the direct underside of the plywood base of Chicago Crossing are the terminals for DCC wiring. What I chose to do was to try to keep the terminal blocks arranged as efficiently as possible. And so in some cases where there was a section with a lot of feeders, I would have one terminal block for the positive pole and then one for the negative pole. However, in most cases, I could actually get away with just having a single terminal block accommodate both poles simply by using jumpers to divide the terminal block into two sides. And that worked really well for most of the uses on Chicago Crossing. I didn't need a ton of different excess terminals, and so therefore I could minimize the amount of real estate taken up by those terminal blocks. For everything else, instead of using the underside, I actually mounted everything on the horizontal beams that create the structure and support for Chicago Crossing. And that was actually really helpful. If you think about it, that's a lot of real estate. And if you're careful about where you drill holes or where you run bus wires and things like that, and try to minimize the amount of crossover between sections on your layout, then you might actually find that in a similar way, you've got a decent amount of real estate in order to mount all of these different little boards and terminals that we need in order to power all of the accessories on our layouts. Aside from that, if you don't happen to have that same sort of geography like I have, another option is actually just to mount a board underneath or a larger cleat that allows you to, say, below the layout, still be able to mount some of that stuff. It still remains attached to the layout, and if you're not moving it around, then it can just kind of live there. Even if you move it around, those sort of expansion boards can also just be made to be removable and allow you to take your layout and shift it where you need and still keep all of the circuitry kind of in one spot to keep it organized and to keep where you have wire drops and the like pretty organized too. So as you can see, there's a lot of different options here as in terms of how you can best organize the underside of your layout in order to maximize use for space for things like dressing and running the wires that are needed to feed all of these different accessories, and keep the terminals for them organized in as logical of a way as possible outside of that realm so that you don't have things running on top of other things. Because I will say, once you start mounting things like turnout motors and the like, you also will see space go away pretty quickly. And if you have manual turnout throws and stuff like that that have their own wires underneath, once again, trying to do the best job possible to minimize the amount of interference between all of these different uses will help a lot when it comes to servicing, expanding, or maintaining the layout that you own. So altogether, that offers you a little bit about what I've learned and what I've done with Chicago Crossing in terms of how to best manage power and how to best manage power distribution and terminals. In the next installment, we'll take a closer look at how to manage wires, because that in and of itself is a topic that's worth its own video. And that was actually an area that I found to be one of the bigger and more interesting challenges to undertake as I redid Chicago Crossing's wiring. So stick around for that, and in the meantime, have a great weekend and talk to you soon.